Welcome back. In the previous class, we have learned about how to use logical operators in C++. We have also seen the fundamentals of logical operators, and moreover, we have tried a program to see the outcome. Today, we're going to learn about binary numbers. You're going to have a question in your mind that we have one more operator, which is a bitwise operator. Why we are not doing that, and why we're coming to this something like very different kind of topic? Well, the reason is simple, that for bitwise operator, you have to know what is a binary number, and you have to have the idea about how to find binary numbers. And this has nothing to do with C++. It is just how you can find binary numbers and how computer works from behind the scenes. So I'll just give you the idea about how to find binary numbers from any number you can think of. And I will show you two ways to do that. One is a difficult way, one is an easier way. Like, it may be easier for you, it may be difficult for me. So whichever way you find easier, you can choose that. I will show you both the ways. So before we move forward, we have to know what does binary means. So binary means here, bi means two in simple words. And I'm pretty sure you may be aware that computer works using two numbers, that is zeros and ones. Zero you can say as false, or you can say low voltage. One is called as true or high volt or something like that. This is sometimes called as off. This is sometimes called as on as well. So these are the two numbers, that is zeros and ones, through which computer works, and that only gives everything in your computer performs, and every action and every function, everything performs only because of these zeros and ones. Now you're gonna think that how so complicated things perform using only zeros and ones? Well, the answer is simple. Whatever you do, it actually converts it to zeros and ones and then perform its operation. Since nowadays computer comes with very high-end processor, it is so fast that even it is not very much capturable through human eye. That means, for example, if I'm writing here n, for example, now this also is happening because of zeros and ones. It is taking all those individual pixels and then converting it, and then it is displaying. So if I have to give you the idea about how binary number works is, first, let's say if I have written number 25, it will be converted to binary code, which the computer only understands. There may be other steps in between, but those steps I'm skipping right now because you just have to concentrate on how to find a binary number from a number. So when this computer understands this number, it will figure out that you're asking about 25. Then it will return back through the same steps where this number, which the computer have understand, which is in binary form right now, it will again convert back to 25 because the human should understand. Not every human knows what is the binary of 25. Then it will give it back to you. So this is a whole cycle which keeps on getting. Like if you press 2 in your keyboard and you see 2 in the screen, this process happens behind. 2 will be converted to binary, computer will understand, it will get back to you 2 by converting that binary to 2, and then it will display to you. Now how this conversion happens? So let's learn that. Let's say if I have a number, let's say 5. Now I have to represent 5 using zeros and ones. Now I will show the first method, which I feel is a little bit difficult method and a longer method. Why it is difficult, why it is long, that also I will tell you. First you see the method. What I have to do is, and one point you can note here is that for binary, 2 is their favorite number. Why? I will just tell you right now. Why 2 is favorite for binary? When you have any number, let's say 5, first I will divide it with 2. So there may be other divisibility technique from wherever you're watching this video, but this is how we divide. So how we are dividing it is that I know that 2 into 2, if I divide like this, for example, if I write here 5, 2 2s are 4, remainder will be 1. So that means I will write this directly. That means I will write here 2, 2 2s are 4, remainder I will write on the side, 1. Fine. So it's simply 2 multiplied by 2, remainder will be 1. That is how we will get 5. That means I have to multiply this two things and then I will add it to this. So I will get 5. Next I will again divide. 2 1s are 2, remainder will be 0. Fine. Now the binary of 5 would be these numbers from the reverse way. So that means 5 is actually in binary we write as 101. Let me show you with one more number. Let's take this time 9. 2 4s are 8, remainder will be 1. 2 4s are 8, remainder will be 1. Then I will divide it. 2 2s are 2, remainder will be 0. 2 1s are 2, remainder will be 0 again. So 9 we write as 1 0 0 1. And remember, it starts from here and then it goes up. So this one is the first one, and this one is the last one. Now you may have one question that till where we have to divide. So you have to divide until you find 1 at the bottom. If I take a bigger number, let's take for example, let's take 31 for example. 31, it's a bigger number. So let's divide 2. 2 ones are 2, remainder will be 1. Then 2 5s are 15. So 2 15s are 30, remainder will be 1 here. Fine. Then we have 2 7s are 14, remainder will be 1 again. 2 3s are 6, remainder will be 1 again. 2 1s are 2, remainder will be 1 again. And since we have reached 1 here, I don't have to divide anymore. So the binary of 31, if we go this way, it will be 1 1 1 1 1. So there's a problem. What is the problem using this method is, for example, you can do 5, 10, 15, 30. That's fine. But what if you get a number like this? If I have 5041, how long do you think it will take us to divide these numbers? So it will take quite a lot of time. So to solve this way, there is one more easier method. So the easier method, it is very simple in order to do it, because you don't have to divide and all those things. Just you have to remember the double of the number. For example, if I write here, let's take one bigger number this time. Let's take 19. Now to find a binary of 19, what I will do is, see here very carefully. First, I will write 1. Now tell me what is the double of 1? It is number 2. What is the double of 2? 4. Double of 4, 8, 16, 32, and it will keep on going. Now, the point is that what you have to check? You have to check first the number, which is 19. Now, 19 is less than which number? That means 32. 19 is less than 32. We have to go till the highest number. That means 16 is just lower than 19. So we don't need all these numbers then. We need till 16 only. So you have to check till which number that particular number which you have taken is greater. Okay, if in case I had 41 here, so I would have taken 32 as well, because 41 is greater than 32. Then 32's double is 64. I would have not taken this because 64 would be greater than 41. So that is the logic. Now if I write here 16 18 16 8 4 and 2, now let's find the binary of this. Very simple. First, if you see the first number and here the first number, I will simply subtract them. So this will be 3, right? So if I take 16 here, 3 will be left. So I will take 16 here. I will put a dot on top of it. Then I have 8. Should I take 8? I have only 3 left. So 8 won't become. Then I have 4. 4 also won't be coming because I have 3. I need 3. I don't need 4. I don't need more. I need less than 3 or equal to 3. Then I have 2. 2 I should take, because if I take 2 here, subtraction, it will stay 1. So 1 is also there. So 1 also I have taken. Wherever you see the dot, I will write a 1 on the bottom and the rest will be 0. So this is the binary of 19. I will show you one more time. This time I will take even more bigger number. Let's take 57. Okay, same way. 1, 2, 4, 8, 16, 32, 64. Now we will not take 64 because it is greater than 57. So we'll stop on the 32 again. First I will subtract 57 and 32. 25 will be remaining. 25 will be remaining. So I can take 32 here. Fine. Let's give a dot on top. Then I have 16. If I subtract 16 here, this would make it as 9. So I have 9 now. So I can take 16 as well. Then I can take 8 also, because remainder after subtraction it will be 1. So I can take 1. Since I have left with 1, I will take 1 from here as well. So that means 1, 1, 1, 0, 0, 1. This is the binary of this number. So it's a very easier way to find binary for larger numbers from the previous method. Okay, so you can try this. You can try solving as many as numbers. You can take your own number also and try solving it. It may happen that at the starting you may do mistakes. It's just about how much you can think of which number you have to subtract and then you have to put. I'm pretty sure if you're doing this for the very first time, you may have some doubts. So do put them in the comment section and do tell me where you have doubt. I will explain that topic one more time, maybe in the next session or in the comment section itself. And do tell me whether you have understood this perfectly. If you need one more, I will upload one more lesson on the same topic, that is on the second method of how to do this. So that would be for the video. Thank you so much for watching. Take care. Bye-bye.